Okay, question 75 says solve the following equations for x. This first option, we're doing all of them. This first question gives us an equation that has both x and y, right? So I know that my solution here is going to have y as part of the answer, right? So if I'm solving for x, the thing that I'm going to do to both sides is add 6y. So I'm going to rewrite this as 4x is equal to, and just force of habit, I'm going to place the 6y first and then plus 20. Of course, if you did plus 6y at the end of the 20, it would be the same. And then what I'm going to do is now divide every single term by the number 4, right? I'm going to push, you can think of this as two ways. I'm dividing each term by 4, or I'm pushing across a 1/4 to each of them. So multiplying every single term by 1/4. If I multiply this first term on the first and only term on the left hand side by 1/4, I get x. If I multiply this next term by 1/4, I'm going to get 6/4 y. And if I multiply the 20 times 1/4, I'm going to get the number 5. I can clean up the 6/4, right? I could write this as x is equal to 3/2 y plus 5. So there we are. I have solved equation A for x. Let's do B. So B has this 1/2. So if I look at this big picture right now, there's only a single term on each side, right? The left-hand side is nothing more than the product of a half and something else, and I just see it as a product. Yes, one of those things that I'm multiplying does contain two terms, but big picture, the left-hand side just has a single term the way it's written right now, and the right-hand side has a single term. What I'm going to do is I'm going to multiply both sides by 1/2. When I multiply the left-hand side by 1/2, I'm left with x minus 6, and on the other side I'm left with, it becomes 18. So that's me multiplying both sides by a half. And there is nothing for me to distribute on this left-hand side, right? There's no negative symbol, there's no value. So this is just x minus 6 is 18. And I can add 6 rather to both sides. So 16 plus 8, that's 8, 9, 10, should give me 24. So I believe x is 24, and just as a real quick check, in my mind I'm going to take the number 24 and subtract 6. When I do that I get 18, and then if I multiply that times a half I do get 9. So x is 24 is a solution. It checks quite nicely. Right, let's see. Let's go ahead and write down, let's see, aren't I clever? Not really. Let's see, C, I have this ratio, I have 4/5 rather, 4/5 plus 18 over x, and that equals 8. So this is a excellent candidate for fraction busters, and I'm going to bust up these fractions, right? There's Racketeer. I'm going to bust up the fractions by multiplying all the terms on both sides by 5x over 1. 5x over 1 will do an excellent job of eliminating these fractions. And I'm just going to go ahead and take the time to write it to show you. So here's a 4, it gets a 5x, right, over 5. Plus there's an 18, it's going to get a 5x over x, and then equals 8, and it's going to get a 5x. So I just want you to see visually that every single one of these terms received factors of a factor of 5 and a factor of x, right? They all received 5x. Now what that gives me is the ability to go in and identify some giant ones and get rid of the fractions, right? So I can do that by first of all noticing in the first fraction that I've got this 5 over 5. So that forms a giant 1, and I'm left with just 4x plus. In the next one, I can see that I've got this giant 1 that is x over x. So that leaves me with 5 times 18. And I think I'll go ahead and do that arithmetic. 5 times 18 is the number 90. It's because 18 is 2 away from 20. 5 times 20 would be 100, so I'm taking away 10. So this is the number 90. Whoops. Let me write that in white. It would seem like it would go with the pattern here. And then that's going to equal 40x. 40x. Beautiful. No fractions. Looks a lot cleaner, easier to deal with. Now what I'm going to do is take away 4x's from both sides. On the left-hand side, when I remove 4x, I have 90. On the right-hand side, when I take away 4x from the 40x that I have, I'm left with 36x. And then to get x alone, I can divide both sides by 36. So 90 over 36 is x. And I can't imagine that that goes in evenly. But when I do the division, it does become it becomes 2.5. So there's definitely some common factors there, and maybe I want to deal with those, or I just want to say that this is 5 halves and just acknowledge the fact that I just cheated and used my calculator, but I didn't really cheat. Come on. What can I divide? I can divide both by divide both by 9, right? 36 divided by 9 is 4. So that's a thing. So I could write this as 9 times 10 over 9 times 4 is 36. So that's gone. And the number 10 is, oh, that's 2 times 5. And the number 4 is 2 times 2. So that's gone. So yeah, I'm left with 5 halves. Whoops, is my value of x. So let me box this one. There's my solution. 5 halves is x. Or maybe I should write x is 5 halves, because I wasn't asked what 5 halves is. I was asked what x is. What is x? 5 halves is x. Well, okay, I guess that works if you talk like Yoda. All right, our last question then is D, and I have enough room that I'm going to write D. Oops. Oh, I'm so sorry. I did not need to show the whole keyboard there. Let's go to D. So D is D. Oh, D has an absolute value in it. So it's 2 plus the absolute value of 2x minus 3, and that equals 5. Let me just check and make sure I got that right. 2 plus the absolute value of 2x minus 3 equals 5. Okay, so let's take a look at this. So we know that when we have this absolute value thing, we use this technique called looking inside. The thing that's difficult right now about using that is the absolute value portion of this equation is not alone. So whenever I see things happening with the absolute value, the best thing to do is to treat it almost like a variable and just solve for that thing, right? So what I want to do is just say, I want to get this entire thing by itself. Well, to isolate that is not bad, right? All I'm going to have to do is just take away 2 from both sides. And if I do that, that's going to become the absolute value of 2x minus 3 will equal the number 3. Okay, what did I do? I just took away 3 from both sides. Now I can say to myself, hey, what can this thing inside of the absolute value be, right? What things can it be? Well, I know that there are 2 things that it can be that would give me an answer of 3. It could be the case that this thing is a negative 3, in which case the absolute value of that would give me 3, or this thing can be a positive 3. So what we do now is we write 2 equations that show that. So I'm going to write the 2x minus 3 is the negative 3, right? Or I'm going to write the other one, the 2x minus 3 is positive 3. Okay, so to solve each of these, I'm going to add 3 to both sides. So let's just do this one first. I'm going to add 3 to both sides. So I'm going to get that 2x is, so when I add 3 to both sides, I'm going to get 0 over here. And when I divide both sides by 0, I'm going to get that x is the number 0. So x is 0 is one of my solutions. X can be 0. The other solution, let's add 3 to both sides. I get that 2x is equal to 6, right? 3 plus 3. I added 3 to both sides, and now when I divide both sides by 2, I get that x is 3. So my 2 solutions are x is 0 or x is 3. And I can come back up to my original equation and think about, okay, what if I do take and I put those values of x in here? In the case that I put in 0, my absolute, it becomes the absolute value of negative 3, which is 3, right? So this becomes 2 plus 3, which is 5. In the case that I put 3 there, right, positive 3, that becomes 6. 6 minus 3 would be 3. Absolute value of 3 is 3. 2 plus 3 is 5. So these two values, x is 0 or x is 3, are solutions to that that inequality. All right, there we go. So that is all of, oh my goodness, that is all of question 75, parts A, B, C, and D.